Let me talk about one more thing. The last thing is deep learning for cars. Well, if it was an amazing year for AI, it's also an amazing year for cars. There are just so many announcements. The fact of the matter is, we all know this. AI is coming to cars. AI is coming to cars. When we thought about helping to create self-driving cars in the beginning, the basic approach was sense, plan, act, using traditional computer architectures, using traditional computing techniques. We're going to continue to do that as well. We're going to continue to do sense, plan, act. The basic loops of self-driving cars is know where you are in the world, figure it, based on a map, also based on your senses, localize. You see what's around you, and then you act. Plan, sense, plan, act. The basic loop of robotics. So we decided to build a computer dedicated for that very functionality. We built the world's first AI car computer. It's called the Nvidia Drive. Our basic approach was this. We would build an end-to-end computing platform, all the way from training the network that would ultimately run in your car. Training the network is the beginning, training your network for your car. As you've heard from all of the leaders, training your network is the first step of having an autonomous driving car. And so we've created a platform that allows you to train on any framework you would like to use. Caffe, CNTX, CNTK that is, TensorFlow, Theano, Torch, you name it. Training your network. And then taking that exact same network, running on something that has incredibly high performance, but has also very high energy efficiency. As I mentioned today with GIE, you could take that network and run it on a car computer. We call that car computer the Nvidia Drive PX. It's the world's first deep learning car computing platform. It's scalable. We believe that AI will be used for car computing, not just for autonomous driving. AI will be used to talk to you. You will give it commands. It'll be looking around in your smart mirrors. Your car will be able to see all around you and tell you there's a bicyclist on your right. Of course, it's going to avoid it anyways, but it's going to tell you. You could talk to it. You could change temperatures. Looking at your gesture inside the car, it could tell when you're dozing off. It could tell whether you're looking in the direction of the oncoming traffic. AI will be used inside the car. AI will be used to drive the car. AI will be used to keep you out of harm's way. We believe AI will be used across the board in car computers. We used one architecture from infotainment to cluster, to ADAS, to self-driving, all the way to mapping. It's a completely open platform. All the APIs are available to everybody. Now, the last time I showed you, we had started working on object recognition for our Drive computer. The thing that's really amazing is only in just a few months, after a great deal of effort, our scientists, our researchers working on our network, has now achieved the #1 score on the KITTI benchmark. This is a self-driving benchmark. I'm super proud of them for doing this. We have the #1 accuracy on KITTI. The thing that's really great is that #2, #3, #4, #5, #6, #7, #8, all GPU accelerated. Working with a large community of researchers that are trying to develop self-driving cars, we're open to work with everybody. We want to encourage everybody to enable this capability so we can make streets safer, so we make driving better, and hopefully it might even change the way we design our cities. Well, let's take a look. Let's take a look at what it can do. Okay, so not only is it accurate, as I mentioned earlier, GIE also makes our network running on our processor super fast. And so we're detecting cars in the front on the upper right, in the back, or no, in front in the upper left, behind you in the upper right, but also in your side mirrors. So the thing that's really cool is that you could detect objects all around you using exactly the same network. And all of that is running on this little tiny processor, the smallest version of Drive PX. This is the smallest version of Drive PX. 180 frames per second, 180 frames per second, detecting cars all around you. Now we can detect lanes, we can detect signs, we can detect anything we wanted to train it to do. And that's really the wonderful thing. That's the beautiful thing about a deep neural network. Whatever you train it to do, it will do. Whatever you train it to detect, it will detect. Okay, so Drive PX. Well, the next thing we like to do, so that's an update on perception. We like to also make sure that you can map. Well, if you want to figure out exactly how to drive and drive safely, you want to have as much information as you possibly can. This is called HD mapping. You could use LiDAR, but we also believe that you ought to use LiDAR and camera and everything that you have. And the cameras will use photogrammetry, basically motion photogrammetry, to do basically what is called structure for motion, to create and identify important points in the surrounding and map and reconstruct a 3D world for you. Okay, that mapping is called high definition mapping, and we've created a platform that allows us to do that. Let's take a look at that. Oh, can we? Well, I think I just leaked that out the door. Okay, excuse the sequence. So Baidu, Andrew Ng and his lab, as you guys know, are working on a self-driving car. And he was so enthusiastic about it, he asked me to share this with you guys. The thing that's really important is this. While you're creating a self-driving car, you've got all kinds of algorithms that you want to deploy onto it. You have sensors and cameras all over your car. What kind of computer would you need? Well, it turns out they need a GPU-accelerated supercomputer. And before the existence of Drive PX2, they had to build their own. They had to build their own. But they have wonderful computer scientists, they have wonderful computer engineers, and they built a cluster, a supercomputing cluster that fits in the trunk of a car. Now, this isn't something that every car company can do, and this isn't something that every car company wants to do. And so the thing that we did was we took all of that supercomputing horsepower and we shrunk it into one platform we call Drive PX2. Drive PX2 has 2 Tegra processors on it, and it has 2 Pascal next generation GPUs that hasn't been announced on it. And so if you take a picture of that and you zoom in carefully, which I know you guys will do, you do it to me all the time. Let's see, hang on a second. I took the serial numbers off. Okay, and so this 4-chip solution, whereas you were looking at a 1-chip solution just now, this 4-chip configuration of the architecture would allow you to basically have a supercomputing cluster inside cars. You connect 12 cameras to it, connect it to your CAN bus, and you can be doing photogrammetry, motion photogrammetry, as well as collecting information from LiDAR, fusing it, in real time computing the map, and instead of streaming up to your cloud 12 high-definition video streams, you stream up to your cloud point clouds that are highly compressed, and that will be accumulated in the cloud over time, crowdsourced by all these cars that are driving around, registered in the cloud to create one big high-definition map. And so this particular platform we are announcing today will also be a mapping platform. The car computer will be Drive PX2. The computer that's in the cloud will be DGX1. End-to-end, exactly the same architecture. PX2 in the car, DGX1 in the cloud. Let's take a look at real-time mapping. So basically what's happening here is that our car, this is using 4 cameras. It's able to detect up to 15,000 important points. It selects 15,000 important points per frame, per second, per camera. And so altogether, the 4 cameras can collect up to 1.8 million points per second. 1.8 million points per second. The points are not only in 3D space, but it is also in color. And so we would accumulate all this information, and we would load it up into the sky, and that would be then registered and calibrated and maintained using DGX1. Okay? So this is mapping. We created this platform so that every mapping company in the world could have the benefit of mapping cars. Building these car computers for mapping it's a really expensive endeavor. You're basically creating a supercomputer that fits into the trunk of a car. But we've now, with Drive PX2, with DGX1, have created an end-to-end computing platform that car computers can use, mapping companies can use. And we have to map the world before all the cars can safely travel around the world.